So what is NMAP and why is it widely used? In simple terms, NMAP is a security scanner which is used to discover hosts and services on a computer network. Its output is a list of scanned targets, with supplemental information on each depending on the options used. It is widely used during penetration testing process because lots of information can be gathered by doing the correct map scan on your target. Information like which operating system the target is using, which ports are open or closed, identifying different hosts on the network, which version of software the target is running, perform vulnerability scan and more can be found out from NMAP scan, which is very useful in the information gathering process. Let's dig into it. What is SynScan? SynScan is the default and most popular scan option for good reason. It can be performed quickly, scanning thousands of ports per second on a fast network not hampered by intrusive firewalls. SynScan is relatively unobtrusive and stealthy, since it never completes TCP connections. It also works against any compliant TCP stack rather than depending on idiosyncrasies of specific platforms as MapSpin, Null, Christmas, Maimon and idle scans do. It also allows clear, reliable differentiation between open, closed, and filtered states. As this example shows, NMAP starts by sending a TCP packet with the SYN flag set to port 22. This is the first step in the TCP three-way handshake that any legitimate connection attempt takes. Since the target port is open, target machine takes the second step by sending a response with the SYN and ACK flags back. In a normal connection, attacking machine would complete the three-way handshake by sending an ACK packet acknowledging the SYN ACK. Since the SYN ACK response already told it that the port is open, if NMAP completed the connection, it would then have to worry about closing it. This usually involves another handshake, using FIN packets rather than SYN. So an ACK is a bad idea, yet something still has to be done. If the SYN ACK is ignored completely, target machine will assume it was dropped and keep resending it. The proper response, since we don't want to make a full connection, is a RST packet as shown in the diagram. This tells target machine to forget about, reset, the attempted connection. NMAP could send this RST packet easily enough, but it actually doesn't need to.